Hello guys. Good morning. The class will run. So let's begin our today class. Although the weather is raining, right? But we after long holiday and the weekend, I hope now it's also the morning, so everybody can be active and energy. Okay? So let's begin our today class. Okay, 问题，第三。Before what we talk in the class is about mechanical property of the concrete. Now let's read. I will read to review what we learned. Mechanical property of concrete, and we propose 3 important strengths. Do you remember that? To describe the concrete. Who can answer me? Just recall what we learned before. And if you have the PPT or if you have to write down the notebook, you can open that and let's review. There are 3 strengths. Do you remember? You are the Dawei, right? Dawei. Yeah, you can do something. There are 3 strengths. Compression stress. Yes. About compression stress, there are also 2. Do you remember? To describe Q, displacement G. QB. Yeah, QB. Compression stress. And what else? Prism. Tensile stress, yes. This is another stress, yes. Well, prism, compression stress, yeah. There's a compression stress and a tensile stress. And for compression stress, there's 2, right? There's a cubic and prism. Yeah. And in this part, we also learned there are some experiments, right? Experiment to how to get this value, this stress value. Yes, and we propose a standard displacement. They have 2 in a standard environment. Yeah. If you not remember the word, you need the video. The videos show the displacement. They carried the test, right? And here in there we introduced the size effect and the friction effect. There's some coefficient to help us if there's no standard displacement, how we can to get the value. Yeah, for the compression stress, compression test experiment. After that, we learned the tensile stress experiment. There's 3 experiments. If you do not remember, okay, read after class. You need to read. This is the important part of this section. And also, what we learned is the curve, stress strain curve of the specimen, the concrete specimen under the unaxial compression. This, just to use another word, is that specimen under one direction compression, right? under one direction? Do you know? Specimen under one direction compression. You forgot? So, do you know, do you remember the stress strain curve?
Yeah, I remember. But it looked like I don't remember exactly.
Because actually it's not clear. Okay. This stress strain curve, right? What I drew in the here. This curve, this stress strain curve. Yeah. This stress is describe the concrete under the one direction compression. Then we get this curve, right? I also introduced the concrete specimen under the biaxial load, right? The curve is different. Right? This is the stress strain. This is the curve, the straight curve of concrete under the biaxial load. And I also introduced concrete specimen under chill axial load. Yes. That's the things what we learn now. And from the part, this part that we know the mechanic, right? Mechanic. Yeah, and we know the mechanic property of the concrete under three direction load. Then we propose the steel reinforced confined concrete type. Yeah, that for there's a steel tube and poured concrete in it. It will used to build the header, the column, yeah, and another members for structure. Yeah, here's the internal logic code that I hope students can master. Yes, for this part. It's okay?
Which one are you supposed to master?
Yeah, for this years we learned three direction loads applied to the concrete, right? And we learned the concrete under two direction load of chill axial load that we propose the type of the reinforced concrete, the steel reinforced confined concrete. Yeah, for this type, this is just a type of the reinforced concrete. For normal that we use the steel bars in the concrete, this is the type of the reinforced concrete. But there's another type, right? There's another type. Yeah, if you have any problems, it's okay. Just tell me, right? Okay, here I quickly to bring you to review what we learned. And here, this is the table list in the code, Europe Code 2. And if students have free time, you can search it online and to download Europe Code 2. And you will see. I just captured this table from the code. Okay? From these tables, they list several concrete strengths. This means the different degrees do you remember there is a critical value to classify concrete is a normal strength concrete and a higher strength concrete? Do you remember the critical value? C50, right? C50. C50. If the concrete weight lower than the C50 means it's the normal concrete. But if its cubic compression stress is larger than the 50, that means it's a higher strength concrete. And look at these tables. Yeah, for there they list here they list the cubic compression strength and the prism compression strength and also the tension, right? Tension strength and also the stream. Do you remember the stress stream curve? Here there's a two stream we need to remember. One is destroyed stream at around the value E is around 0.0033, right? Yeah. So here this table almost lists different type the concrete. There is a character values. Yes. And maybe in the future, or maybe in the next semester, that you need to finish a design work. There is a will related to which type concrete you will use in the structure design. So if you do not clear about some character values, you need to go to read the code and to find. So this table will be workable, will be useful. It will be useful. Okay. So here, I use these figures. End of this part. Talk about the concrete. Okay. And in there, we go to the next section to learn the shrinkage and creep of the concrete. Yeah, there it belong to another part. Okay, if you do not, if you think you do not master the before the part, before the section, you need to read the PPT after class. Now we will begin another. Yeah, I think that before part is enough for us. So now we just go to the next part. For shrinkage and creep, creep, from the meaning, from the word meaning, I think everybody can have a rough way to know, what the shrinkage. Shrinkage means the value be smaller, right, for concrete or material. For creep means that the values will be larger. Yeah, this thing seems complicated, right? Complicated. But this different character just happen to the concrete. So we need to realize how these things, this phenomenon occur on the concrete. Okay? Yeah, so now let's read the definition. Definition of the shrinkage. The value reduces when concrete is hovering in air. Right? There's include two parts, the plastic shrinkage and the drying shrinkage. Here we know for concrete we mixed the several ingredients. For the water, for the aggregate, sand, cement, together they pour the water, the hydration. So during the hardening in air, the shrinkage just began happening. So look at these figures, they may vividly to show you, because different ingredients, there must have the empty between the ingredients. They are the bubbles, right? Bubbles in the city. During the hydration, the water will escape, right? Escape. So the volume, the empty will, the empty will be fulfilled another thing, air, right? Air in the bubbles. But bubbles, airs can pressure, the volume can change. So this phenomenon, we call it the shrinkage. Okay. Right? Yeah, water in evaporation. Yeah, drying shrinkage depends on current conditions, temperature, and humidity. This is the drying shrinkage, and another before this is the plastic shrinkage. Plastic shrinkage is the material, like the cement. This material, during the hydration, his character change. And for drying shrinkage is the water evaporation. There's the bubbles inside. So here, we need to realize there's two shrinkage for fresh concrete. There are bubbles with in the air, the bubbles, the waters escape, and here the empty here comes the air in there. Yeah, let's look the pictures about what the shrinkage will cause the problem. What the problem of the shrinkage bring to the structure. So there is a crack, right? Crack, because for the empty, they easily to break. They no sand, no aggregate to support the material, the concrete. So we will find some structure surface to crack. There's a no load applied to the member, but it's also developed a crack, right? Crack, and the surface of the road. Yeah. So the shrinkage is really a problem, right? Really a problem to the concrete. So for us, we want control. We want to reduce the shrinkage during the hydration. Right? Yeah. So let's to realize how the shrinkage that develops with the time, right? With the time. So from this curve, yeah, this one is the stream, right? Just the deformation of, we can realize this one just fresh concrete, the value, how the value change, the principle that he drew, and this is the time, Yeah. We found just this is the curve, right? Curve, but the decreasing rate is decreased. The rate is decreased. At the beginning, it's really fast, because during hydration, the waters run away, right? Run away. Yeah. But later, yeah, after they still had a shrinkage, but the rate is lower than before, right? This is the rate. But for concrete, the shrinkage strength always increase with the time. Always increase with time. Just the rate is different. Right? Rate is different. This is the curve that used to describe the shrinkage. Okay. So that's the shrinkage developed quickly reach 2, it will reach to 25%. Almost we think this one is 1%, but in the beginning of the 2 weeks, 14 days, the shrinkage already reached 25%. Right, 25%. But after 2 weeks or 4 weeks later, it half, right? Half. A month. The process of shrinkage can be extended for more than 2 years. This time, after the 50%, they around 2 years to reach the final shrinkage value. So this is also a character phenomenon that about shrinkage. At the beginning, it quickly developed, but after 4 weeks, a month, yeah, it grows slowly. Okay. Yeah. Now we know the character phenomenon of the shrinkage, how it developed. So some researchers, yeah, they controlled some parameters to help us to realize the principle. They do several experiments and want to obtain which parameter or which things will affect the shrinkage. So they do the experiment, and what they get drilled in these figures, right? For these figures, this one is the shrinkage. We can realize the shrinkage. This is the time, right? Time, and there's a four curve. This four curve represent different ratio. Water divide cement, and the water's content. Then this is the cement ratio. Water divides cement ratio. Less water in the mixture, so the less water is steam, so less shrinkage, right? So the water divides cement. If this ratio is lower, that means, so we mix concrete, you use less water, right? Less water. So less thin, let's recall that, yeah, just to think that it will affect drying shrinkage. Right? Drying shrinkage is related to the water, and the plastic shrinkage is just related to the material, the skeleton of the concrete, just like the cement. So for here, the higher cement concrete increasing the shrinkage of the concrete. Higher cement means it will affect plastic shrinkage. The cement, this cement also has its own character of the here. So for these figures, we know the magnitude of the ultimate shrinkage scheme, so related to the cement and the water content, and just to know, the less water, less shrinkage. And if you use because cement, we do not mention the cement degree and matter, because for this one it's hard to control, right? Because for we to want to make the concrete, this one will produced by the local factory, so it's made hard to control. But the waters we can easily control. So for us, we want less shrinkage. So during the mixed concrete process, we need to realize the water is an important factor that affects the concrete shrinkage. Okay, this is the one. And another is the elastic modulus and the gradations of aggregate. Aggregate in the concrete is support. Support. Just provide the strength to the concrete, right? Because for concrete we build the cement and the water just a smooth things that beside the aggregate. For the aggregate, exactly, they also influence the shrinking by offering the restraint to the paste. Because for concrete, right? For concrete, this is the aggregate. This is the cement around the aggregate, right? If the cement they want to, there's a plastic shrinkage happen to the cement, right? But if there is a full of the aggregate, it will restrict the cement. Yes. It will offer restraint to the paste. And another the current conditions. Current condition. It will affect the water evaporation, right? There's a summarize the researcher summarize three things: cement and the water content, and the elastic modulus of the aggregate, or the gradation of the aggregate, and the third reason is the current conditions. Okay. So if one day the exam, the question is please write the reasons to control the shrinkage. Please write something to control. You need to know. Here's the three, right? These three. And these three factors. And here I leave you an interesting homework, right? Just to think how to measure the shrinkage. Because before we just directly provide the stream of the shrinkage, or just have the shrinkage values, but do not mention how to use which method to get the shrinkage. So just leave this interesting homework, let you to find some material to read and to know how we to measure shrinkage. This is the second interesting homework, right? Well, until now, up to now, I do not leave any homework need you to submit to me, right? But just interesting homework for you to widen your knowledge, to learn different things. Okay? Here is the second. I do not request you to finish on which deadline or submit to me. Do not meet. It's not unnecessary. Let's leave this small interesting homework. So for this part, and here, before we know the phenomena, the shrinkage and the shrinkage type, and which things will affect, which factor will affect the shrinkage, and now here, let's realize how exactly the value will occur in the concrete, right? Occur in the concrete to do some calculation. Yeah, look at this concrete. Right? This is the original member. Right? If there's a no steel bar, yeah, we can imagine, right? Because for the fresh concrete, we build and put water during hydration, shrinkage will happen. There is a shrinkage. There is a stream caused by shrinkage. Okay, right? Before, yeah, I mentioned this one to this here is the shrinkage caused. Right? But if there is a steel bars in the concrete, reinforced concrete, okay. Also the fresh, the concrete, right? But to here, they only shrinkage the stream cost. The shrinkage only is at the single SC. For this one to there, this is the shrinkage cost. This is the stream caused by shrinkage, right? The unrestrained. But for this specimen, this one is the steel bar. They will provide a restraint to resist the concrete shrinkage. Just is the reinforced concrete. We put the steel bars in the concrete. And this is also for the stream caused by shrinkage. So for now, I introduced exactly the relationship exists in here. Yeah, for we learned material mechanics, right? This is the stream, right? Stream, and the stream CS. They have the relationship, right? Yeah, can you understand this formulas here? For this one is we do not have the steel bar that caused by the shrinkage, right? This is the big values. But but if the steel bars in the specimen, they also affected by the shrinkage. So they also have the stream caused the shrinkage, but this value is less than before, right? Because of the restraint of the steel bar. So this value is smaller, and so then we can use this value to cut to this values and get this is the restraint stream provided by steel bar here. Here I will ask Wenqi, can you explain this formula for us? So what are you doing before what I mentioned this formula?
We're trying to analyze those notebooks. Since I can just see that reducing, we don't understand.
You don't understand?
That's right.
I say it again, okay? Yeah, okay. Everyone, tension. Do not focus. So, do not see these two specimens. We only see the first one and the second one. This is the stream, right? That's caused by shrinkage. Yeah, it is the totally stream. And do not see the second one and the last one. And we just imagine there has the steel bar in the concrete. They also will have the shrinkage, but this stream value is smaller than the specimen don't have the steel bar. This one you can imagine, right? Because the steel bars in the concrete, they will restrict for the concrete. Yeah, they just like a support to resist the concrete shrinkage, right? So this value, to compare the specimen, this had the stream value. Yeah, stream value. And we can use so they had the relationship of this one is totally the concrete shrinkage. For this one is they had steel bars. They had steel bars to shrinkage, and for this one is the steel bar provide the resist. This is the string, right? This is they are all string, but the meaning is different. Okay. Yeah. So from these figures we build the relationship, right? The string relationship.
That one is string, then CS. What do those?
CS. CS means just to help us to distinguish. Yeah, this one CS means look at here. Here they use this symbol to represent the shrinkage, right? The concrete shrinkage. Maybe you can the concrete, right? So you may use the CS, okay? CS. And for the CT, maybe it's concrete tension, not tension, because here the CT is the steel bar. Steel bar, they provide the restraint to the concrete, to not concrete shrinkage like before. Yeah. I think CT and the CSC here, he just a symbol to represent this type the stream. Yeah. For SC is the shrinkage, right? This shrinkage is occurs to the reinforced concrete here. Yeah, we needed to know this string relationship, and then we can do the calculation to know the shrinkage will cost how much, how big the stress in the concrete. Here. Yeah, it's okay. I will continue. For these figures, I just want you to know the relationship between if there's a shrinkage, how many streams will occur, and if there for the reinforced concrete,